Welcome to Study Loop.
Ozone. Let's draw the Lewis structure for ozone. Start out by looking at oxygen on the periodic table. It in group 6 or 16 has 6 valence electrons. But we have 3 of them. So let's multiply that by 3 and for total of 18 valence electrons we have. So that how many we have to work with draw our 3 oxygen right here. And so we have 18 valence electron. Let's start by putting 2 between each of the oxygen there. That forms a chemical bonds. Let's check now and see if we have octet over here. So if we have octet over here, 8 over here, so those have octets, but in the center this oxygen has only has 6. We need 2 more valence electrons. What we can do is take 2 from the outside and share them. When we do that, we form a double bond. So we have fulfilled the octet rule of each of the oxygen. The only problem is we could have a double bond over here and the single bond here. Both are correct. And one last thing, we do need to put brackets around it to show that it has a negative charge. This compound does not obey the octet rule by extended valency shell. Now for XCF2, let's do the XCF2 Lewis structure. Xenon on a periodic table has 8 valency electrons plus fluorine has 7. Although we have 2 of them, so we will multiply that by 2. That's all gives us a total of 8 plus 14 is equals to 20 valency electrons. So xenon is the least electronegative. It will go at the center. And we will put the fluorine on the outside. Now by putting the fluorine outside, so we have 22 valence electrons. Let's form chemical bonds by putting 2 here. So that 4, then around the fluorine. So we will still have 2 valence electrons left. So we still have pair of left. So I could try to form a double bond with fluorine. But I know fluorine is very electronegative. It doesn't normally form a double bond. So I also know that xenon can have more than 8 valence electrons. So I am just going to put the xenon extra 2 right here. What we will do now is we look at the normal formal charges to see if this is actually the structure that makes sense or we may be need that double bond. Let's take a look at the formal charges. Then, so on fluorine right here, we have 7 valence electrons because it in group 7 or 17 on the periodic table. We have non-bonding electrons, 6 of those and then 2 bonding electrons which we divide by 2. 7 minus 6 of those, 1 is 0. For the xenon, it's in group 8 or 18 has 8 valence electrons. We are looking at non-bonding. We have these 2 and then up here these 4 for a total of 6 and then bonding electrons we have 2 4, so 4 divided by 2, 8 minus 6 minus 2 is 0. When I look at the Lewis structure for XCF2 and I look at the formal charges, I can now see that the formal charge are 0 and that is this is going to be that best Lewis structure for XCF2. Now lastly SPF4 minus. So let's do the Lewis structure for SPF4 minus Lewis structure. Sp on the periodic table is in group 5. So it has a 5 valence electrons plus fluorine has 7 valence electrons, but we have 4 of those and adding up here negative 1 is total of 34 valence electrons. So we will put Sb on the center and then 4 fluorine atoms on the outside around it. So we have got 34 valence electrons. We will put 2 between atoms to form the chemical bonds So there are 10 electrons surrounded the sp including sb. Now, the compound does not obey the octet rule by extended valency shell. Now, let's calculate the formal charge for the non-zero atoms. Recall the formula for the formal charge is Fc is equals to group number minus bonds plus non-bonding electron. So, calculating for the Fc of antimony Sb, the Sb is equals to 5 minus 4 plus 2 is equals to minus 1. So SB has the formal charge of minus 1. I hope you understand this well. Thank you.